All right, go ahead and get started. Thank you, everybody, for coming. This is probably the best attended Lunch and Learn I've done this year, so thank you for showing up. My name is Jacob Dunn, and I work at the Integrated Design Lab, part of the University of Idaho. My background is in architecture. I got my Master's of Architecture from U of I, and starting the lab is when I really got introduced to energy modeling. I have been doing it for about 2 years, about 2 or 3 years now, under Ari Janady, who some of you might know. He's our guru over there. And he essentially has taught me and some of the other folks at the lab how to do a certain type of energy modeling, EnergyPlus and OpenStudio, which essentially is what we're going to talk about here today. But before I get started, I just want to take a quick poll from you guys in terms of, are we all mechanical engineers? Yes. Some structural, or is it pretty much all mechanical, some electrical, stuff like that? And then who has done energy modeling themselves? Okay, so has anybody ever heard of OpenStudio and EnergyPlus? Or a little bit familiar with it, but just at an introductory level? And what programs have you used for energy modeling? EQuest. Cool.
Yeah, I'd say from Travis, who will be joining us in Missoula, he does a lot of EQuest energy modeling.
Excellent.
We've also, I think, as a company, some folks have done probably trace.
Okay.
That, HAP.
Yeah. Excellent.
And then I've personally done spreadsheet modeling for utility incentives, individual measures, that kind of thing. Yeah, I've done some of that too.
Perfect. Yeah, and as you guys know, that there's really not one program that's used to energy model. It's really a whole host of programs that use to support it. My background mainly is in EnergyPlus. I've looked at EQuest a little bit, but generally I really only know EnergyPlus. So keep that in mind as well as we go through that perspective. Let's see. Let me click on this. This is working. There we go. So in general, mission statement of the lab, for those folks that aren't really familiar with it, we essentially do 3 things. Energy efficiency research, we do sustainability consulting for local architecture and engineering firms, and we also do outreach programs like this. And then we're also part of a lab network that's distributed throughout the Pacific Northwest. There are 5 other integrated design labs. They're all affiliated with the university, and they all do some amount of that same kind of scope that I mentioned before in terms of teaching, efficiency research, and also consulting. And then in terms of our actual shop right now, we're pretty much evenly split now between architects and engineers in terms of the project manager level and also the interns that we've been doing. So we just graduated Chris Dyke. He got his master's. We helped pay for it. We got to help direct his thesis. And Carlos is still working for us currently, and Shreve's just about to start school in September. So we also, not only do we preach an integrated design process, but we've been slowly trying to build in an integrated design team as well, so we have better perspective on these types of projects. Funding by university, different organizations, government, and then also local utilities. Then all right, so now on to the actual presentation. So I'm here generally to talk about workflow. And from an energy modeling standpoint, this is a workflow that really is looking to use energy modeling to leverage better design. So not necessarily about appliance modeling for code or even for different certification programs, although that is a really important function of energy modeling. But this is about how do we define a workflow with energy analysis that helps the architect design better buildings, helps the engineer design a more efficient building, and how do we integrate that with the entire design process, not just from a documentation standpoint at the end of the process. Then, of course, specifically, we're going to talk about EnergyPlus, and really why EnergyPlus. It's been a research tool mainly for the past couple of years. It's difficult to use. You see it used by a lot of universities and kind of hardcore research institutions, and it's a pain to use in a lot of cases. But one thing that we are trying to talk about today is some of the developments that have gone into EnergyPlus, specifically its front-end developments, and in general why we use this as a tool. And these 4 reasons are generally why we choose to stick with this as our main course. Since essentially you can do the entire spectrum of design with EnergyPlus, from architectural loads to doing facade iterations to the most detailed HVAC analysis that you can imagine. And also recently it's integrated radiance daylighting, which is probably one of the best daylighting tools out there in terms of accuracy. So all of that's kind of wrapped in together now that you can do from start to finish with EnergyPlus. And then that's kind of ultimate flexibility is also one of its downsides in terms of you sacrifice some kind of usability and kind of intuitive input outputs because it's so powerful and it is so flexible. So that's kind of a double-edged sword. Also, we do a lot of passive design analysis at the lab, and EnergyPlus has a lot of kind of internal calculation engines that can handle that very well. And also there's some kind of plugin programs or post-processors that are integrated within the code that can do things like advanced node-by-node airflow network modeling for natural ventilation. You can also do Earth-2 modeling. It's a bidirectional heat flow algorithm, so it's really good at doing thermal mass and night flush because it does that bidirectional heat flow modeling. And also one reason, too, is that it's kind of the new guard. So eQuest was really the horse of the Department of Energy for the longest time, but now it's not being supported quite as much as EnergyPlus. So really all the developmental dollars are going into EnergyPlus and more specifically OpenStudio. So a lot of the certification programs are requiring EnergyPlus models. A lot of the California utility incentive programs are. So it's just something that's going to become more and more ingrained, I think, in common practice. So in terms of what we're going to talk about today, we'll talk about the kind of different ecosystems of energy modeling with EnergyPlus and kind of drill down specifically to what those strengths and weaknesses are. We'll look at the different workflows of just energy modeling in general, and also workflows for defining windows versus opaque constructions versus HVAC. How do we use EnergyPlus to do that, at least at the lab? And then if there's time, we'll talk about an example of a recent project that we took through this process that I'll be talking to you about today. Some resources that you can go to post this presentation that kind of will give you some additional background, and also the future of what this workflow is going to look like. So first, let's talk about ecosystems. The first one is just using EnergyPlus bare bones, Textmode, all in the back end. And that's really quite painful, but a lot of people did that for the longest time. They would do geometry in Textmode, and Ari still likes to do that at the office. I can't understand it as an architect, but you can actually design fairly simple and some moderately complex geometry all within Textmode. Blows my mind. The next one, which has been really popular, is Design Builder to EnergyPlus, and this is a proprietary front end that is really well developed, well supported since it is private. It can do energy and daylight analysis, rich front end, good input-output, graphic capabilities, but it costs money. So we generally don't use that at the lab because we try to be able to pitch open source free software. Yes, sir?
Quantify
the cost? I used to know what it was, but I don't know the most recent one. So I'm not comfortable throwing a number out there. I'd say maybe $5,000 to $10,000 a year for a license. I had to throw a stick in there, and that's basically well, and that's the university license as well. So when we get quotes for something like, yes, it's all the university modules, and we're still surprised at how much it costs. But there's a reason for that. It's well supported, and it's a good interface. The next one is Symergy, which is a free one that's probably the newest one to come out. It's developed by the Lawrence Berkeley National Laboratory, and it's heralded as the eQuest killer in terms of it was designed for engineers that used eQuest. Because it's a really rich HVAC design interface too. So it'll do all the front-end stuff in terms of loads, envelope specifications, so on and so forth. But it really has a really good HVAC design interface. We're using it on one project currently, and it's still in the initial stages. And we're kind of, the jury's out still from the lab in terms of if it's going to really develop into something that's usable in a professional basis, or if it's kind of going to stay in the research route. And then what we're going to talk about generally is the OpenStudio EnergyPlus workflow. It's all free, so open source. OpenStudio is being developed by the Department of Energy. It's rapidly developing. It's in version 1.0 now, so we've been dealing with it, at least I have, for the past 2 years, starting out at version 0.4, and it's been getting better and better on every release. And in general, this can handle the entire design process as well. So this is, we're going to go into OpenStudio in depth. But in general, too, at the lab, when we talk about the ecosystem of EnergyPlus that we model with, it's really all these support programs that are being used in conjunction with EnergyPlus. So EnergyPlus is the main calculation engine, the back end, and then we're using all these programs to help do the different parts of energy modeling. So for instance, Sketchup is used for geometry, it's connected to the OpenStudio Sketchup plugin. Then we actually use a different OpenStudio application for doing all the load specification, energy model management. We use Notepad++ as the text editor for EnergyPlus and maybe the back end of the OSM files. We're using Windows 6 to do custom Windows specs. Excel is still a really powerful tool that we use all the time for doing side calculations that we feed in EnergyPlus and doing results visualization. And OpenOffice is something that we use for kind of text file generators because it's also open source and the area knows the language for that more than it does for Excel. So we use all of these things in conjunction with EnergyPlus. But for our purposes, I'm going to focus on kind of these three big ones in terms of EnergyPlus, Textmode, OpenStudio Application, and also the OpenStudio Sketchup plugin, which is where we handle a lot of the geometry and some loads modeling and specification. So as we move forward, I'm going to talk about how we use these three different programs in tandem to do these different parts of energy modeling. So first, let's talk a little bit about the strengths and weaknesses of each one of these programs. So there's the OpenStudio Sketchup plugin. It's really great for geometry manipulation. Sketchup, first and foremost, is an architectural design tool. A lot of architects already know how to use it. It was an easy kind of transition for me, but it's a very intuitive, very easy modeling program to use. It's very rich in applications for the type of geometry modeling that energy modeling requires, like surface matching or doing intersections on thermal zones and stuff like that. Also, they've done a little bit of Ruby script integration with some of the menus, so you can do things like set window to wall area ratios for all of the thermal zones with the push of a button with the scripts, or shading device protrusions, or you can start to report different parts of the spaces with some of these scripts, and you can also write your own if you're staffing in Ruby. This also is a good interface for space type application, which we'll get to a little bit more later. And then this interface also provides good import-export functionality for importing IDF text chunks and also spitting them back out for going in between this particular program, the application, and Textmode.
Can I ask you a question about this?
Absolutely.
So I've been working on getting OpenStudio set up on my machine.
Sure.
And it seems like in order to be effective using the Sketchup plugin, you really need to use, you have to have a paid version of Google Sketchup.
There's been a little bit of confusion around that just because Trimble bought SketchUp recently, and now there's SketchUp Make. And it still has some of the Google stuff in it, which is a little strange. But you can still use the free version of SketchUp, and it should run just fine with the free, OpenStudio's free.
Yeah, I guess, but it doesn't have a lot of the features that you do the geometry with, so it's not really...
It should have all the geometry features. The main thing that you don't get between the free version and the pro version is exporting to different types of 3D geometry files. At least that's the only thing that we've run into issues with. So let's say I wanted to export this to an Ecotech model to do other types of analysis. You can't export this as an OBJ or an RBI or anything like that. But the free version should get you everything that you need. Yeah.
Okay. I guess it's a matter of getting that set up. Because when I go into my browser, a lot of the toolbars and stuff aren't there. So.
Interesting. Yeah, well, and I can work with you on the side on that, so we have a little bit of funding for that just to see if we can get set up.
Yeah.
Exactly. Then some of the weaknesses is that it's not really a parametric modeling program like you'll start to see with Project Sari or Grasshopper and Diva. So, if you make a modification to this geometry, you almost have to remodel it, right? So that's kind of one thing that you don't get with SketchUp.
Can you elaborate on that? No.
Sure. So in some cases, there are no parameters that are defining the kind of overall geometry of this. So if I wanted to do, let's say 20 different iterations of maybe a surface area to volume ratio so we can start to test that, I'd have to remodel this 20 times. In some programs, you can hook it up to a visual programming interface to where you can actually just set up an automated run to where it will automatically go through those changes, modify all of the space types and their dimensions, and run the analysis, which is really cool. But those are very research-based tools. There's not really a defined workflow that can do that easily yet, but it is out there. And I think SketchUp will get there. So also it's a little bit unwieldy, so this is something called the inspector, and this is where you can actually dig into some of the inputs of the energy model. And really this kind of three-window classification is really unwieldy to do any kind of deep model management. So you've got your categories up here. This, if you select that, you've got your list of objects down here. And if you select that object, you've got an interface for manipulating that one object. And it is just a pain in the butt to kind of go through this and try to understand where everything goes. So generally, we try not to use this for that, and we really just stick to geometry manipulation and a couple of other things. Also, it's still a little bit buggy despite kind of how the version that it's in. Sometimes the geometry will perform irrationally when you start to do surface matching and you have to kind of remodel it a couple times. Sometimes, it'll just crash unexpectedly. Hasn't really been too much of an issue, but it can be generally frustrating. Then also, the program is still separate from a lot of the other programs, and I'll talk a little bit more about that. So this is the plugin. So that's directly into Sketchup, and then there's the OpenStudio application. So there's this kind of schism in version 6 or 0.6, and now there's a separate program that will run a lot more of the model management. And actually within that program, there's a bunch of other programs as well. So the plugin is technically part of this OpenStudio package. But for all intents and purposes, I separated it because it's one of the major things that we use. But so OpenStudio Application is where we do a lot of the energy model management, libraries, inputs, putting in construction, space types, loads, stuff like that. Then also there's a parametric analysis tool, which is very new. We haven't played with it much at the lab, but this is where we start to get into some of that parametric capability, to where we can run a sensitivity analysis on like a night flush system and do 20 different thermal mass configurations in a very quick and automated amount of time, right? So this is going to be very powerful once it starts to get developed, and we can start to find workflows around that. There's also Results Viewer, which is just a separate program you can view results in, a separate Run Manager where you can queue up energy model runs, stuff like that, and also a building component library. And these guys really are integrated into that OpenStudio application. So when we talk about it specifically, its strengths are really doing any of that low definition construction management, application stuff like that. And it's really a much better interface than what we saw in the Sketchup plugin. So in general, this is a space type, so you've got these kind of different tabs that are all the major parts of the model: schedules, construction, space types, thermal zones, stuff like that. You've got, like an object kind of menu here. This is a specific space type, so this is all the details of the space type, including like, the loads that are in it, the outdoor air object and stuff like that. And then this is kind of your library management. You can see there are separate tabs for that, where you can start to drag and drop a lot of those library objects into that model, right? So this is just very general interface stuff. Don't worry about being able to read everything, just a general overview. So, it's a rich user interface. You can do HVAC modeling in OpenStudio now, drag and drop interface. It's very nice. We'll talk more about that later. You can run your model directly from it. You can't do that in the Sketchup plugin. And there's also integrated with the building component library. There's a certain amount of results that you can view within OpenStudio, the application. And then also, recently they've added the radiance capability, so you can do very detailed daylight analysis within OpenStudio, which is a huge improvement to the workflow.
Can you input like a Revit block from the building?
You can. There is a workflow for that, but it's really a Revit model to a GDXML export, and then you can import that into EnergyPlus or OpenStudio. It's a little not super smooth, but that's getting more and more developed as well. The DOE just, I think, put $2 million into a research project for gbxml.org to kind of define some of those pathways on how you go from Revit to some of these more powerful energy analysis programs.
Would you use this, because I use hack to do load calcs, and would you use this in place of that? Or
You could, yeah.
You wouldn't need to do half at all.
You would need to, yeah. And there are some, benefits from going with this kind of time step dependent energy model versus HAP, which is a really detailed spreadsheet, right? It's doing loads modeling. This you could do a lot more in terms of the detail of passive systems, and then also in terms of running different scenarios or looking at the loads throughout the energy analysis period, throughout the weather file period versus the design days, and also trying to come up with like different ways to slice that up to do right sizing and stuff like that. So you just get a little bit more information if you handle loads here.
What would you see like the input quantity of time would be for something like this versus like a half?
From all these kind of front-end, developments, I would say they're comparable. Like it used to, I would say that half is, let's just say, 10 minutes, and then with this, it was probably like 10 times that much, right, before OpenStudio came out. But now, since a lot of this is automated, there's a lot of templates with the library management. If it's a fairly simple model, I'd say it's probably just twice as long. Like you're actually starting to gain a lot of ground on some of the other tools in terms of how much it takes. And really with this, though, since you're setting yourself up for the full range of analysis, you get some more benefits if you start out with this process, even though it takes a little bit
If
more
you're
time.
going to do
If you're going to do holistic
if you're
integrated
or
design,
not.
then yeah, sometimes a spreadsheet might be just what you need versus doing an energy model program.
So Dustin, if I did my load calc in this on an income store, could you use this for your energy rebates? Would it be helpful?
Yeah,
Would you leapfrog up?
So the rebates, a lot of times they require energy calculations for the custom incentives. And the ways that you can do that is basically you have to talk the utility into the fact that this thing saves energy. And so they'll look at either a spreadsheet calculation or whatever justification you provide them. But if you point to an EnergyPlus model, they're much more apt to have a lot less questions as to the energy savings because they know the underlying calculations were done right. And so if you could get it to that point where, man, if we designed it in Revit, we kicked it into this energy model, it would be a pretty straightforward process to just give that to the utility and say, here's how much energy savings we have, and then they incentivize it.
Yeah,
Absolutely.
That was the next question I had. If we had a project come to Revit, we could export it in, how much time do you think that gap, you said double the time versus half, do you think that gap is smaller?
If you start with the Revit model?
Yeah.
Depending. Yeah, it can be. Although, really, if you're going from Revit to this, depending upon the experience of doing the GVXML exports, sometimes it's easier just to remodel it in SketchUp, and that can be really quick as well because it's very simplified thermal zone modeling. So really, still though, starting from Revit, doing HAT versus doing OpenStudio, it's probably still going to be a little bit more time.
Have you worked in Energy Pro at all?
I have not worked in EnergyPlus. I'm familiar with it, but haven't done a lot
What
with
you're
it.
looking at.
Is it similar to kind of the same layout as this then?
They're all very different in terms of the way they structure their interfaces,
Yeah.
and there's some very unique things that OpenStudio is doing in terms of its library management that makes it really quick to do a lot of the energy model inputs, and we'll cover a little bit more of that.
Does it go into California requirements? Energy Pro is designed around California, so it tells you hacks.
Spits out what you need for the compliance. That's one thing that's it's really just the bare results, and even like if you want to try to take this into lead, you have to kind of translate everything manually. There's a couple of programs and plugins out there that can help certainly shape those outputs towards like Title 29 compliance or towards code compliance, but generally it's just the bare outputs. All great questions.
So one thing that I've seen that this has a big advantage to is the EnergyPlus engine, the calculation method can be used by lots of different software programs. So this OpenStudio is really just a front end.
Right.
It's free. But like I think Train is going to move to EnergyPlus as an underlying calculator for train trace. And so I think the industry standard is going to kind of go to this as a calculating engine, and then this OpenStudio is really just the interface to do the calculation.
That's what we've seen.
We just need to get Energy Pro on board to integrate theirs into this thing.
I don't know, and maybe they do already, I don't know. It's possible that they already use EnergyPlus as the calculation engine. So like eQuest uses DOA 2.2,
Right.
which is an older, similar in EnergyPlus.
It's usually a hostile interface, yeah.
And so you can check on the Department of Energy's website. They have a really good simulation tools database, and you can look up Energy Pro, and it'll give you a lot of those that information about what is its underlying calculation engine, who's developing it, what version is it in, and gives you some really good kind of information on that. So you can always check there. One of the weaknesses of going into the OpenStudio application is you can actually change between IP and SI inputs, but you can only output in metric. You can convert all of that to IP if you're in text mode, but it's interesting because you sacrifice a little bit of that flexibility by having this front-end wrapper, right? So you can't access this one object that would allow you to convert everything to IP. So that's a little bit frustrating in terms of I really want to output in IP and not have to convert it, then we have to open up the back end a little bit, which isn't a big deal, but it's just one extra step in that workflow. I imagine they'll fix that with the following versions, but they haven't yet, which is
And who made this?
the Department of Energy.
And they did it in metric.
Yeah. Well, EnergyPlus originally is all metric. Yeah.
We had a huge argument, discussion, I would say, in our pod about metric versus SI system, and all the engineers were like, except for him, was metric all the way.
Yeah, we have that constantly too, especially between the architects and engineers, because we're used to seeing it in definitely IP, and it's a little bit harder, I think, for us to get off of that. But always a good debate. Another thing about this type of interface and a lot of the kind of front ends is that you can really only select one zone or one model at the same time. So if we're starting to try to apply things to multiple zones, if we have like a 200 zone model, this can get a little bit laborious. So there are some strengths to going into something like Textmode, which is just the pure back end, right? So the strengths are it's completely flexible and completely transparent. So what you see is what you get in terms of all the text objects that you're cutting and pasting from different files or from the manuals to define whatever you're trying to energy model. So we're not getting that loss of translation from this, which OpenStudio creates a .osm file, and then when you run it or export it, it exports it to the .idf file, which is what is actually the calculation engine is based on. There's a little bit of strange translation syntax and a loss of transparency between that translation. So when you're working in text mode, at least you know what you're working with is what's doing all the calculations. It's nice too because you can do some text and expression-based filtering, so you can start to do replace alls. You can start to manage large models and deal with it that way. And also this is a good way to integrate with our spreadsheets and our macros in terms of being able to copy and paste in spreadsheets that are linked to tables that have loads of information in them that we get from the client or from the design team, and be able to translate it more easily into that in a text-based interface. Some of the weaknesses is that it's essentially all text, and with an architecture background, sometimes it just hurts my eyes to look at 50,000 lines of text for more than 4 hours at a time. But I know some people have a better tolerance towards that. But that really also makes it hard to navigate sometimes too. There's not a good way in Notepad++, although it's probably the best text editor, to do bookmarks and really kind of get some good signposts in there, so we can jump around that 50,000 line plus text file a little bit more easily. And of course, that makes QA/QC a little bit more dicey when you're kind of trying to pass these files off to other people, and they're just giant text files. So one thing I want to touch on real quick too, part of the OpenStudio application was the building component library, and this is fairly new to version 8.8 of OpenStudio. And so now they have this kind of online portal that's open source to where they're trying to aggregate libraries of constructions, loads, space types, even HVAC components, and even energy efficiency measures, to where you can just input that into your model and run it from there instead of having to define everything up front. So I mean, this is going to revolutionize at least the workflow for OpenStudio as more people contribute and as it gets more and more developed. Before, you could only really download the OSM file and then kind of manually import it into your model. With version 1, it links directly to it, so you can actually download LED lighting measure with daylight harvesting into your model and run it directly from this interface, versus having to kind of script and edit everything up front. Also, it's kind of a good kind of team management structure. You can set up a group and start to share files and work from there. So this is going to be a big deal moving forward.
Question for you.
Sure.
If you say you're going to model a building and you're more focused on HVAC, do you have to do a full lighting model in it to get all the watts per square, or is it just like a enter 1.2 watts per square foot?
Generally, you can keep everything at the defaults, and it'll do based on a code cycle, so you don't have to get in there. But it does need to specify that to do all the heating and cooling, balance load calculations from those internal loads with the HVAC modeling.
Because you don't have to lay out the lighting in your model.
You don't. No, it's just it's a lighting power density that you put in.
Okay.
But you can get into that. You can actually do it fixture by fixture if you wanted to, but we've never done it like that. We've always just done lighting power densities. So let's see. So let's talk a little bit generally about workflow. So the conventional kind of parallel workflow, when we're trying to deal with this from a design standpoint, just a simplified version, we've got conceptual design, 2 versions of schematic, and also design development. Essentially, you start off with an architectural model and conceptual design, and then when you get into schematic design, you'll start to see maybe an energy model pop up and a daylight model. Currently, sometimes this workflow is too unwieldy, the feedback loops aren't quick enough, or else you would see these kind of in the conceptual design phase, which is where we like to see them at the lab, right? There's a lot of value that energy daylight modeling can do when you're in those initial conceptual design stages. So right now, it kind of begets this parallel workflow. There's a lot of coordination that needs to happen between these 3 models, especially if 3 different entities each own this model. So there's the architectural model, energy model, maybe that's done by the engineer. The daylight model, maybe that's done by the architect, or it could be done by an energy analysis, a third-party company. And And there's all of this kind of coordination that needs to happen. If something changes in either one of these, let's say the daylight model determines that the windows need to be moved up 2 feet. That needs to get translated to the energy model, needs to get translated to the architecture model, and vice versa. So it's a very unwieldy way to kind of move forward with doing a lot of design iterations. Because as you start to move forward, that loop starts to become really prohibitive. So what we like to try to pitch is this integrated kind of vertical workflow with energy modeling, where you start out with an architectural model that's linked to an energy model and daylight model, which is essentially what OpenStudio does. It really integrates these bottom two to where they're completely effectual towards each other. So as we start to kind of move through this process, you don't have these parallel workflows. Change the energy model automatically updates the daylight model and architectural model, and then when you move forward with the new design iteration, all of those changes are updated within that, and all the analysis is housed within one model. And that really is, I think, the workflow of the future, because that allows you to have a lot more freedom in changing designs and really going through an iterative process and not having to slack through all this kind of coordination and workflow. So let's zoom into the energy model. So this is like the design process workflow, and there's definitely an energy modeling workflow for just that one section of this process. So essentially we're going to go through each of these 9 steps and talk about how we use the Textmode, Sketchup plugin, and the OpenStudio app to do each one of these different phases. And this is really kind of weird, tenuous dance that we're going in between those 3 programs throughout the entire process. So generally, though, the strategy is to use OpenStudio for as much of this as possible. And with each new version, you're able to get kind of farther along the process versus like beforehand, we had to stop in OpenStudio whenever we got to HVAC definition because they didn't have a good way to do modeling. But now with the kind of drag and drop interface, you can pretty much run through the entire thing. You really only need text mode for doing more advanced HVAC analysis and iterations. So that's the general strategy: is OpenStudio as much as possible and text mode as little as possible. So workflow number 1, which is geometry creation. We talked about using the Sketchup plugin. Pretty straightforward. I mean, I like showing this image because this is a hotel project that we worked on. We recognize this from the shape. It's the Riverside.
So I was thinking it looks like the Riverside.
It's like we called it the frog from up top because it looked like a frog. But so Sketchup has an X-ray vision kind of visualization layer to where you can actually look through the walls, and it's a good tool when being used with energy modeling because you can actually see surface boundary conditions. So you can make sure everything's matched correctly by being able to look through the walls. But geometry is pretty straightforward. It happens pretty much all in SketchUp. When we get to something like space type creation, there are different options that we can use generally moving forward. So I'm going to try to explain the differences between those. Or actually, I'm sorry, space type creation, we generally only use the OpenStudio app. And that's because we get a lot better library management, much better interface, and also there's a lot of starting templates that you can use just right out of the box. They have 16 space types from schools to warehouses to offices that contain a certain amount of space types, all with their own default or code-based loads based on the different code cycles, which is really nice. They're good starting points to use. However, though, so like let's say with Office, they really only have like Office and I think Corridor, and I think that's it. So like if we want to do conference room, high level, low level, medium use, then we have to actually modify those space types or create new ones, which we would do in the OpenStudio application. And then one of the kind of really nice parts about this interface is that OpenStudio follows this kind of hierarchy of inheritance in terms of how we apply that space type or these loads or this construction to the entire energy model. So it kind of goes up and down, starting out at the broadest level, getting down to the surface. We've got the building level, story levels, the space type level, the space level, and then also the surface level. So for instance, let's say we have a construction that we want to apply to the model. Let's just say it's a mass wall. And so first OpenStudio will look at the surface and say, did the user apply that construction to the surface? And if they didn't, it'll look at the next level up, at the space level. Did they apply this generic default wall to the space? And if not, it'll go to the space type. If not, it'll go to the story until it finally hits something, and then that's what it'll use to modify. So you can be very surgical and very quick about the way you apply some of these things to your model. It's a little confusing at first, but what's that?
Where you can have broad.
Yeah, we'll talk a little bit more about these for each one of these workflows. So generally with the space type, step 1 is you create or modify your space types. Step 2 is you adjust the loads. So like this is a people load. You go to a different tab this guy shows your loads interface. This is a people definition. You put in your number of people, or people per square foot, or square foot per person, and then you move on to doing scheduling, which we'll talk about later. So that's general workflow. For workflow 3, which is construction creation, there are really 2 pathways that you can take. So option 1 is with the OpenStudio app. They have great templates for all the constructions by client zone and also by code cycle. So generally, if it's a baseline building, you can just use their baseline construction set, and you're good to go. You can also import constructions from the building component library. Are you guys familiar with the ASHRAE Advanced Energy Design Guides by chance? Have you seen those? They're just research documents that the ASHRAE's made for like 30% efficiency versus 50% efficiency. And so they've made like instructions for those documents that you can download from the building component library, which is really nice. Or you can create them from scratch, which is a painful process. I don't recommend it, but sometimes you have to do it. This is the construction tab. This is like your sandwich layer of materials. You can click into your materials tab and see everything here. And then this is how you define specific heat, density, insulation values, and stuff like that. And, this is a lot more input for each material than you get with some unidirectional heat flow programs like EQuest or HAP and stuff like that. And that's because it's really trying to calculate the thermal mass balance of the materials as well. So you really get that thermal mass effect embedded within the heat calculation engine. Option 2, if you don't want to use the OpenStudio app, you can do it all in text mode, which it looks like this, a little bit more painful. But what's nice is if you do a lot of these in text mode, you can import them via the Sketchup plugin and then modify them in the OpenStudio app. So a lot of times we'll still create instructions in text mode and then just kind of import them in. And they do have a kind of a library in the installation folder that's all of the ASHRAE Handbook of Fundamentals materials in that. So if you want to do expanded polystyrene, we could create a text object, look in that library, bring it over, and then import it into the OpenStudio versions. And that's usually a pretty good workflow. So however you define it, after you define it, you actually aggregate those constructions to do a construction set in OpenStudio Application. And this is essentially defining the default constructions for external surfaces, internal surfaces, ground contact surfaces, windows, and stuff like that. And so this way you can apply that at the building level, and pretty much all of your construction will be taken care of. And then if you need to kind of override the surface, you can override it at the surface level or space type level. So if you have like a first floor that has CMU and the top floors have studs, you can actually modify it that way. But applying your construction set at the building level will usually take care of all of your construction specification in one step. It's completely automated. Okay, so workflow 4, which is fenestration creation in Windows, it's a very similar process. You can do it in OpenStudio, or you can do it in text mode. You can import from the building component library, or you can actually also go into text mode, and they also have a library files where you can pull windows that they've made with various performance parameters. I mean, it's a giant file, and it's really hard to manage. So what we've done is we created a bunch of windows from scratch using Windows 6, and we translated them to a text file, and then we made them available for import on our website. And we'll talk more about the website later. So this way, all you have to do is import this kind of window set into your model and then apply it from there. And we have a spreadsheet that talks about the different performance parameters. So we have like code windows, we have thermally unbroken frames, thermally broken frames, organized by vintage and stuff like that. So this is a much easier way to kind of go through it than to try to use their libraries or try to just create them from scratch in OpenStudio. Regardless, however you kind of bring them in, we still apply them in the OpenStudio app, similar to no matter how you did your constructions, we apply them in the OpenStudio app. So moving on to scheduling, option 1 is your text mode, and essentially it creates compact schedules only. So this syntax defines a fractional schedule for, so it's a little hard to read, building occupancy, fractional schedule through 12/31 through the entire year for different types of days, summer design day, weekday, Saturday, all other days, and this is the actual occupancy profile. So this can be hard for people to get their heads around, especially when we have new interns coming in their first learning modeling, but it's a very compact, simplified way to do a whole year's worth of scheduling. And these can be imported via the Sketchup plugin as well, so you can always get them into OpenStudio very quickly. Option 2 is the visual interface for doing scheduling, and this is within the OpenStudio app. And it does a different type of schedule, which is a rule set schedule, which is actually defining it day by day. So I mean, the text file for these rule set schedules are gigantic compared to this, I don't know, 50-line object. But since it's all happening within the OpenStudio interface, you don't actually have to deal with that. But if you do export this into text mode and you want to try to edit that, it can be really difficult. So you always have to kind of be aware of when you're going to switch over to text mode completely, if you're going to do that, versus what you want to do in OpenStudio. So really understanding that threshold can be really important to doing an efficient workflow. So no matter how you define your schedules, similarly, you apply in a schedule set, just like there's a construction set. So we have a space type construction set. This is just for medium office. And we can apply our occupancy schedule, lighting schedule, people schedule, stuff like that in here, and then apply it to the space type, and it will get applied for medium offices. Or we can make a break room schedule set, make a conference room schedule set. So essentially this is applied at the space type level versus the constructions were applied at the whole building level. Space types have a lot more diversity. All right, so now scheduling. And so now once we have all this set up, which is like the first step in the process, we need to actually apply those space types to our geometry in our model. So there are two ways to do this, as there are multiple ways with all of these different workflows. The first one is actually to apply them directly in OpenStudio in the Facilities tab. So in one of these tabs, there's a expandable tree-level style view of the entire energy model. So it's like the building, the stories, the different spaces, and it actually breaks it down into walls, windows, stuff like that. And then when you click on one of those spaces, you get all of its information, which is its building story, its construction set, and then also its space type, which is right here. And so you can actually drag and drop your space types into that and change them zone by zone if you wanted to. But once again, if you have like 50 zones, that can be really laborious. So option 2 is using the Sketchup plugin, and you can apply space types to multiple zones within this guy. So there's a button called Set Attributes. You can select, like 50 spaces, opens up this dialog box, and you can apply a space type to everything that you selected. So in general, we'll always go back to the Sketchup plugin to specify the spaces because we can do it, in batch, essentially. So that's a good way to handle space type designation once they're all created. So I mean, it kind of is rough that we want to make it in OpenStudio, the application, but we want to apply it in the plugin. It's all this kind of going back and forth between these programs because they all have different strengths. So workflow 7, HVAC design. Okay. So this interface was developed, I think, OpenStudio version 0.6, and it's a really great, very rich HVAC design interface that I really like to use. Essentially, it's drag and drop components. They have templates for all of the ASHRAE Appendix G baselines. So you plop in this packaged rooftop units. You can select on each one of these components, and it'll open up the actual attributes for the cooling coil, the heating coil. You can modify pretty much all of the parameters that affect that, and it's all packaged into this system. But you can also do custom air and water loops to where you don't have to remain on those templates. You've got all your components in your library. You can go through and make custom loops. This is just a hot water loop, with different pumps, your different pipe connections, and your different plant equipment. In this case, it's a boiler. But even now with the building component library, you can bring in a lot of other pieces of equipment that you didn't have to do, and it saves you from doing node-by-node connections that you have to do in some of the other energy modeling programs if you want to get to this level of HVAC detailing.
And it's just the equipment. That's all you look at. You're not looking at network layouts.
Pretty much, yeah. I mean, you've got a little bit here. So, like, if this was a VAV system, you could do VAV, reheat, hydraulic, or electric, in some of the ductwork. But the nice thing about these is essentially it takes care of all of those ductwork connections and pipeboard connections for you in the template system. If you did it custom from scratch, you would have to define all those yourself, which is very few people can do it, and it's just takes a lot of time. So that's pretty much what we're getting into when there's text mode, although there is a template version in the text mode, and we've actually created this generator, which is a macro-based OpenOffice generator spreadsheet where you just select what your system is, and it will spit out the objects that you need to define for your model. So there's a lot more templates available in Textmode than there are in OpenStudio. So you could do like a water source heat pump loop with varying plant equipments and cooling towers versus it's harder to do in OpenStudio. These ones will create them for you. But in Textmode, you can do the node-by-node custom systems. There's ultimate flexibility. You can do pretty much any system as long as you're trying to use some of the example files and also just your own knowledge of the systems. It's very hard to do. So generally, I've only dealt with using these templates or using the OpenStudio templates. But Airy will actually do custom systems that aren't supported by those two types. And then also, we can do the OpenOffice generator, so we can do large projects and it can all be automated. And of course, you have a lot more options in this one here. And there's also a little bit visualization of what those kind of custom loops look like. If you download the Squiggle SVG viewer, this can be really good for troubleshooting. It visualizes all of your energy text objects and how they connect to each other throughout your model. So that can be really helpful as well. All right, so almost at the end of the workflow. So workflow 8 is actually, sure.
Skip over something here.
Yes.
We've got spaces and we've got HVAC systems. How do you
Excellent.
design one together?
Excellent point. So there's the thermal zone designation, which can be done in OpenStudio, also through here. This tree view is spaces, and there's also a thermal zone drop-down. So you can create the thermal zone and then apply spaces, or here you can actually do thermal zone, create new with space. So when you make a space, it'll be a thermal zone.
The thermal zone has an HVAC system.
That's how it reads it into the HVAC system. Absolutely. And then so if I wanted this whole top floor to be on one thermal zone, I can group that if I wanted to, like if the zoning made sense or something like that. And then this is your thermal zone right there that you can drop in. Great question. So when we're running the Energy Daylight model, depending upon which program you're using, there are 3 different options. One is just a separate application. It's called the Run Manager. It can run IDFs that have been created in Textmode, or it can run OSMs that were created in OpenStudio. It's the most comprehensive. We never use it. We're only using option 2 or option 3. Option 2 is just for Textmode. There's this EP launch application. It has batch capability and it also has some post-processor capability. So if you want to do the lead average baseline, there's a script in there that will run it and will spit that out for you for your lead counts and stuff like that. But if we're using OpenStudio, we run it within that interface. It's got a Run Manager Lite program within it, and it'll run the OSMs. You can batch them as well, and it's pretty much the same thing. The only main difference between these different options is the way that it organizes the output files, which is frustrating because it should be consistent. But these will do a little bit deeper way, a couple of different subfolders when you're running in post-processing, because it has to translate OSM to the IDF, then it spits out like 15 output files that you can then post-process. When you run in Textmode, they all just come at the highest level of where the IDF was located. So I mean, there's some idiosyncrasies between where it puts those files. So when you're running in the OpenStudio app, you can actually do the daylight analysis. It's got the radiance option, which you can actually just click right there. It's that radio button. You do have to add some geometry and some analysis grids in the OpenStudio plugin, but you can run it from the application. And it's really rich. I mean, you get a time step analysis for the entire year, all radiance-based. You can get flood maps of the actual daylight. This is actually zoning and air temperature.
So the purpose of this is to generate abstract artwork?
Not quite, right? So half of the battle in energy modeling is getting it to output data. The other half, which is potentially more important, is how to interpret this data for design, right? And this is just one snapshot of the entire year. Sometimes these flood maps can be more important in terms of this would be mean level of luminance for that analysis grid throughout the entire year. So you get a whole year's worth of the performance. They'll also just give you a daylight autonomy number, so it's doing very complex annualized metrics because of the radiance engine. And then also, probably most importantly, is the script will actually take this annual run, and if you're doing daylight harvesting, it will redo the electrical lighting schedule and actually have that be affected by the radiance run, which is unprecedented in general.
Define daylight autonomy.
So daylight autonomy is the percentage of time over the year that a certain node or sensor point is above a certain level of illumination. So it's really an annualized metric for understanding how the space performs. So let's say this point right here has a daylight autonomy of 50% at 30-foot candles. 50% of the time throughout the entire year, that sensor point reads above 30-foot candles. So
With no electric light.
with no electric light, all daylight. Then there's even spatial daylight autonomy, which is spatial metric, but we won't get into that. But the point is, you can get very detailed analysis within the energy model that can also affect the energy calcs, because EnergyPlus has a native daylight analysis engine, but it's not very good. I mean, generally, one program can't do both, which is why it has to link to radiance. In this case, you get the best of both worlds. So when we start to look at the results viewer, there are 4 different ways to visualize results. Option 1 is in the Sketchup plugin. So you can actually render by simulation data. So you can take that annual run and apply that information in the graphical output to either the zones or the surfaces. So this one's looking at surface outside temperature. You can change the day of the year and the time of day and animate that. So if you're starting to look at interior surface temperatures for night flush, you can really get a visualization of what that is, which can be useful. Option 2 is you're running it within the OpenStudio app. It's got this native run manager lights and also a results viewer. It'll give you a little bit of outputs. These are very basic though. You can open up the table for the annual building utility performance specs. It's pretty much all the kind of pre-cooked tables that you get, coil sizes, loads, trim gain, stuff like that. Option 3 is the actual run manager program, which is very powerful. It takes all the hourly output variables specified in the model, and you can do line or flood plots and of those variables, and you can also compare them against each other. So this can be really nice if you're looking at plant hoop temperatures for multiple runs, and you want to understand seasonal reset to see if it actually works. You can use this tool to do that. And then it also has the annual pre-cooked tables in it as well, which are pretty much the heart of the outputs that you get. Last but not least, there's Textmode. So it spits out all these output files. There's a CSV. It contains all of your hourly output information over your time step. So sometimes you'll have 400 columns of all the zonal analysis, 8,760 rows. If you do a 1 hour time step, sometimes we do 6, and these files get to be like 3 gigs of text, right? So they can get crazy. But they're the most flexible, right? So we'll do a lot of custom post-processing with Excel right out of these CSV files. All right, so let's see. I've got 8 minutes. I think I've got time to go through the rest of the program. I think that's good. So in terms of an example, I want to actually walk through how we used it on our project. So, this is a workflow that we actually have vetted and works. And so we did recently a project that's a net zero prototype for Idaho, essentially. So it's all new construction, suburban sites, and we're starting from scratch. And we're really trying to understand energy savings over a baseline code building version, and also what would be the energy demand they would need in terms of the amount of PV they would have to produce on site. So in terms of that kind of 9-step process, we'll go through each one of those for this project. We did the geometry in SketchUp. Here you can see that the geometry of the building. We're using this kind of slicing section plane tool to check the surface boundary conditions. The space types were imported. We had to do there were 15 space types that we had to define, so that was the first step as I went through and tried to create additional space types with the loads according to the design of the project. So we worked with the architect and the owner to define what those were, brought them in, applied them in OpenStudio. The default constructions we're able to leave as is because it was ASHRAE 2007, climate zone 5B, and it just applied them automatically. But we did have to change some of the envelope. We did a thermal mass system, which was a concrete sandwich. So we had to define that in OpenStudio, which we did, and then apply that on the proposed run. So we're able to model this system with all its thermal mass capabilities and put that into the model, all within OpenStudio, the OpenStudio application. Fenestration, we, for both the baseline and the high-performance windows we spec'd, from our website, we get the table of the different, windows that are available in that text file, imported into the file, and then applied it in OpenStudio. But, this is just a nice way to start to filter and look for the actual type of window that you want. Each one of these has a text object associated with it that you can import and apply to your model. Try to streamline the process. And then all the scheduling done was in the OpenStudio app, so we did the visual interface versus the compact schedules. We applied the space types in in SketchUp, going back to that, here you can actually just click on one of these and see what the space type is. The baseline, we were able to do the HVAC. The baseline was, I think, packaged VAV systems, all within OpenStudio. But the proposed system was a multi-zone VRF system with heat recovery, so we had to go into Textmode for that. So we could do everything in OpenStudio except this one step, which was advanced HVAC modeling, in which we had to export everything to Textmode and then create this using one of our OpenOffice generators that will do a VRF system and then plug that into the model. Yeah, it's the first time we ever did at least take it that far, too, where we used OpenStudio for the baseline HVAC modeling. So then we did daylight autonomy runs in OpenStudio, but we still had to do the renderings, this guy, in SketchUp to Ecotech to Radiance parallel workflow, which I'm embarrassed to say, but it just wasn't quite there when we did the project, so we could do it all together. And you really can't get good, perspective visualizations out of OpenStudio yet, but I think they will integrate that further down the road. The results, we post-processed everything in Excel. We had to get this level of these iterations for the different packages, put them all together. We're automatically showing the savings and the different end uses. We had to post-process that all. We have Excel templates that will do this for us. We're looking at the peak profile, cooling profile for the different options as well, because we're really trying to downsize that PRF system. And then also just a pie chart of the savings as well. And we're also able to get from the model the energy demand in kWh of all these components. And then we were able to calculate with PV watts how much they could produce on sites if they plastered their entire roof with PV and also put it on the shading devices. And you can see they were close. So we did some more back and forth with them to try to manage that discrepancy. So the last 4 slides are some resources in terms of where you can go if you want to learn a little bit more about this workflow specifically, or if you're interested in energy modeling in general. So the first one is kind of this new website that we designed this year. It's the BSUG 2.0 website, idlboise.com/BSUG. And this is really created to help support the energy modeling community. So we have a whole modeling resources sidebar that has protocols documents. It has calculation spreadsheets that we've done. So like we've automated doing baseline fan energy calculation and translating that to EnergyPlus inputs. It has, IDF objects that you can paste directly into your model, lead modeling resources. I mean, all of your energy modeling resources are here. And then we also have, like training links to other websites like this. We have video archives of our BSUG meetings that we do every month, so you can go on there and check out some of the videos. I'll probably post this one on there potentially, see how that goes. We have the forum, where you can ask questions. There's a blog where I blog about energy modeling interest stories, quite entertaining. And then also there's upcoming events, which talk about things like our monthly BSUG meeting, which is free for people to attend. It's every 3rd Wednesday of the month. And we generally have local, regional, or IDL presentations on various modeling topics. And you get free lunch if you RSVP. So this upcoming one on August 21st is me, once again, talking about an architectural concerns about energy modeling. Still would be useful for engineers to go to, because as architects try to kind of take more energy modeling on up front, we'll need to know how to work with them better throughout the process so we can be an effective team. So this is just one example of one of the types that's coming up in August. 2 months ago, we had Malcolm Cook from the UK come in and talk about doing CFD modeling, which was an international speaker that we were able to bring in. So definitely recommend checking this out and attending some of the meetings if you're interested in energy modeling in general. We've also are just about to publish this BusPro document called Building Simulation Protocols. And this document essentially is probably like a 50, 60 page Word doc with tables and graphs and charts, essentially documenting this presentation in terms of here are each of the different types of energy modeling activities. This is our workflow, and importantly, this is the baseline resources and references in a high-performance reference. Yep, no problem. So that can be really useful for trying to understand the workflow and standardizing what you use in terms of your assumptions. Definitely a good one to check out. And it's really all about the lab's workflow, so it's a good insight. And then last but not least is the actual OpenStudio website. They've got some great user documentation for all the different programs. They've got really good training videos, and they have interactive PDF diagrams that will go over every button in the Sketchup plugin and the OpenStudio application. And there's a lot of buttons. So this really gives you a good look at how everything relates to each other. Also, you can engage the lab in terms of working with you on projects. So we've got some funding from Idaho Power to work with some of their customers. And phase 1, phase 2 work is everything less than $3,000. We can cover all from Idaho Power, no cost to the owner, engineer, or architect. And this is to do simplified analysis, maybe work on proposals, maybe things that have a research stint, looking at projects that save kWh. And then if we go into anything above $3,000, it's a 25-75 cost split. So the owner, architect, engineer pays 25% of the cost, and the utility pays 75%. So it's a great deal. It's designed to work on projects with a research bent. It's designed to transfer our knowledge to firms. We're not trying to take any work away from the private sector, but we're trying to transfer in the market to be able to take these skills that we talked about today and work with the profession and get those skills transferred, essentially. So if you're curious, feel free to email me. If you have any projects coming to the line that you at least want to meet about, we're open for discussion on these guys. So last but not least, the future of OpenStudio. I think eventually there's going to be a completely integrated BIM workflow that happens from Revit. All the energy analysis happens within Revit. I think that's a big trend that's going on right now. The building component library is going to get more and more robust. Everything you'll be able to get from the building component library, which will be great. Better radiance functionality, I think, is on the horizon in terms of better visualization and also doing the actual renderings of perspectives, all within OpenStudio. And then also the parametric capability is going to get more and more integrated into the OpenStudio application and become a lot easier to use for everyone, which will be really great in terms of that workflow. So that's the end of the presentation. We can field a couple questions, but please make sure you sign the sign-in form and also fill out